So, good afternoon, and this is lecture number 3 in our quest for excellence. We were dealing with motion in 1D, and we were dealing with questions on average speed and average velocity. Yes or no? Do we remember this?
Yes, sir.
We had done some questions on average speed, and where I'd asked you what is the average speed. Average speed is total distance divided by total time. I had given you certain questions for practice. We will continue on this. We will do more questions. But let us first move on to today's first definition. We are done with speed. Now, what should be our next venture? What is the next thing that we must deal with now?
Velocity.
Velocity is the next heading. That is absolutely correct. So write the next heading, and the next heading is velocity. So I hope everyone can see my screen. Next heading is definitely velocity. Now, as soon as velocity comes into the mind, now we had denoted speed by S, so we'll denote velocity by V. Okay, now what are the things that we must remember about velocity? What if I say the word velocity, what does it remind you of? What do you think is velocity? Yes, tell me now. Let me just place it here. That's the better.
Rate of change of displacement.
Rate of change of displacement. Okay, that looks like a good definition of velocity, but I must correct it here somewhat. It is actually not the rate of change of displacement. It is the rate of change of position vector with time.
Okay, sir.
It is the rate of change of position of the particle with time. So that is a better way of writing this. It is the rate of change of position vector of the particle with time. How the particle is changing its position, or how the position vector of the particle changes with time, that rate is known as velocity. Many a
Yes, sir.
times you would have heard, and that's not very wrong also. Not correct, but that doesn't mean that if something is not correct, is wrong. Rate of change of displacement with time, but that is exactly not correct. So I will write it as rate of change of position vector with time. What type of quantity is velocity?
Vector.
It is a vector quantity, so you must remember this. Therefore, whenever I write velocity, I must write this. I must write this vector sign, so that it is clear to me that it is a vector. Now, if it is a vector, it must have two things. What are the two things the vector must have?
Magnitude and direction.
It must have a magnitude, it must have a direction. So whenever we talk about velocity, you must talk about these two things, magnitude and direction. What about the SI unit? The SI unit of velocity. What is the SI unit of velocity?
Meter per second inverse.
It is meter per second. Why are you taking so long? And what is the dimensions?
L
L
theta
T
minus
minus
1.
1. Okay, no doubts on this one. Now, as soon as we get into velocity, we must now get into what are the different types of velocity that we might encounter. Types of velocity that we may encounter. Yes. What is the first type of velocity that you might have heard about?
Uniform velocity.
Yes, that is uniform velocity. Now we have different similar meaning terms for uniform. Instead of calling it as uniform velocity, I can also call it as
Constant velocity.
constant velocity, or I can also call that the velocity remains
Same.
same with time. Now let us understand this uniform velocity. Let us understand this uniform velocity as I always do it point wise. So when I say velocity is uniform, the first thing that must come to your mind that it is covering equal particle as equal what? Equal
Distance.
displacement in
Equal time. Interval of time.
equal intervals of time. Do we understand this? The particle has equal displacements in equal intervals of time. That is the first way you understand this. Or you can also say that the velocity remains constant or same with time. Now, when I say velocity remains constant, there are two parts in which it should remain constant. It should remain constant in magnitude and it should remain constant in direction. Do we understand this?
Yes, sir.
If the particle is moving with uniform velocity or constant velocity, the velocity must remain same. It must remain same in magnitude. It must remain same in direction. There is one more way in which I can understand this. A particle moving with uniform or constant velocity, I can also understand it this way. It is moving with same speed, constant speed, or uniform speed also in the
Same direction.
yeah. So it is moving with constant speed, constant or uniform speed in the same direction. If it changes its direction, it is still moving with uniform speed, but it is not moving with uniform velocity.
Velocity. Yes, sir.
Do we understand this?
Yes, sir.
Even if it comes back, for example, if I throw something up, if I throw this up, let us assume that it is moving with uniform speed, but if it turns back, even then the speed may remain constant or uniform, but
With
the
the velocity.
velocity will change because the direction changes. Do we understand this?
Yes, sir.
So that is what you can understand. You can understand uniform velocity as uniform speed in one direction. So this is how you can relate uniform velocity with uniform speed. Do we understand this? That is the only relation between them.
Yes, sir.
That is the first type of velocity. Have you noted it down?
Yes, sir.
Then what would be the second type of velocity?
Non-uniform velocity.
Non-uniform,
Velocity.
or you can use the term
Variable velocity.
variable velocity. Just give me a minute. I think there is someone on the door. Just give me a minute. Okay.
Sure, sir.
Okay. Non-uniform or variable velocity. What would you mean by non-uniform or variable velocity? The name tells us everything about this non-uniform or variable velocity. So it will travel or cover unequal.
Unequal displacement
The body will have unequal displacement in
in
equal
equal
intervals
interval
of
of time.
time. Or I can say velocity changes. Velocity changes with time.
Time.
Now, when I talk about velocity changing with time, it can change in magnitude, it can
It can
change
change
in,
direction.
or it can change in both. Do we understand this?
Okay, sir. Yes, sir.
Can you give an example of velocity only changing in magnitude? Only changing in magnitude, but not changing in direction. So you can say if you throw a ball up, when the ball is going up, it is going in the same direction.
Direction.
Direction does not change, but
But
the speed
magnitude
or the
change.
magnitude changes. Yes or no?
Yes, sir.
Then you can give an example of velocity changing only in direction but not in magnitude. You can take the example of uniform circular motion, a body moving in circles with the same speed. The speed is same. That
But the
means the magnitude
direction
is same, but the direction is continuously
changing.
changing. Can you give an example where both are happening? Well, if something is moving like this, or the way you move on road or vehicles move on road, they are moving with non-uniform velocity because they are changing both magnitude as well as the direction. Do we understand this?
Yes, sir.
So that is what we call non-uniform
Non-uniform
velocity,
velocity.
velocity changing in magnitude or
Or
direction or
direction. Or
both
in both.
is known as non-uniform velocity. Then what will be the next heading?
Average velocity.
Yeah, the third one would be average velocity. The third would be average velocity. What is average velocity? If you understand the first term that we did, you can tell me what is average velocity. Yes, what is average velocity?
The total displacement by the total time taken.
It is definitely total displacement divided by total time. That is average velocity. And how I'm going to write it? V के ऊपर arrow, velocity put in a box. That becomes the average velocity ka symbol. Do we understand this?
Yes, sir.
Total displacement divided by total time. That becomes my average velocity. Now I can also write. Now I can also write the formula for average velocity. Remember, vector is important. Average velocity V in a dabba will be equal to delta R. Delta R vector is total displacement divided by delta T. Do we understand this?
Yes, sir.
This becomes the formula for average velocity. Do we understand this?
Yes, sir.
You can write this formula in this way, or you can write a formula from here. Total displacement would be equal to what?
Average velocity by time.
Multiplied by time. So you can write the formula in this way as well. Do we understand this?
Yes, sir.
These are the two ways. Or from here, you can also find out how much time it takes. Total displacement divided by the average velocity. Do we understand this? Yes or no? No, yes.
Yes, sir.
Average velocity. Remember, this average velocity is always calculated over an interval of time. Do we understand this? Between 2 points.
Yes, sir.
Whenever someone talks about velocity between 2 points, he is always talking about average velocity between here and here, between your home and school. What is your average velocity? Total displacement divided by total time. Do we understand this?
Yes, sir.
Well done. Now we have talked about the average value between 2 points. We take our journey to the next thing, which will be velocity at any given instant. And that velocity will be known as
Instantaneous velocity.
instantaneous velocity. Instantaneous velocity, I will represent it by the V vector, and that becomes the symbol for instantaneous velocity. Now, as soon as you see the same symbol as it is used here to the symbol that was used here, and I will repeat my words. Whenever someone refers to velocity, which velocity is he referring to? When I ask you what is the velocity, which velocity am I asking you?
Instantaneous.
I am asking you the instantaneous velocity. Therefore, instantaneous velocity in short is what we call as velocity. Do we understand this?
Yes, sir.
So we can call it velocity at any instant. We can call it velocity at any instant. We can also call it the rate of change of position vector. Do we understand this?
Yes, sir.
Rate of change of position vector with time. So now I can write the formula. V vector will be dr vector by dt. Do we understand this?
Yes, sir.
dr vector by dt. Now one more thing you must understand here. This instantaneous velocity, if I talk about this instantaneous velocity v vector, it will have two things. It will have a
Magnitude.
it will have a magnitude and it will have a direction. Yes or no?
Yes, sir.
The magnitude of this instantaneous velocity, if you find out the magnitude of this instantaneous velocity, what will that come to? That magnitude of instantaneous velocity will come equal to your instantaneous speed. Do we understand this?
Okay, sir. Yes, sir.
The magnitude of this instantaneous velocity will be your instantaneous speed. So you might have heard this saying that velocity is speed with direction. Whenever you heard that term, velocity, speed with direction, you actually talked about the instantaneous velocity. Instantaneous velocity is instantaneous speed with direction. For example, you are again on a bike or on a car, and I ask you, what is your instantaneous velocity? So how will you tell me your instantaneous velocity? You will first look at the speedometer. Okay, 40 kilometer per hour.
Yes,
That
sir.
gives you your instantaneous speed
Instantaneous
or
speed.
the magnitude of instantaneous velocity, and then you add direction to that. 40 kilometer per hour towards east, that becomes your instantaneous velocity. Do we understand this?
Yes, sir.
That is how we understand. So going back in time, going back in time, going back in time, if I move to this point where we were discussing instantaneous speed, remember there was a symbol that I used for instantaneous speed, that was V without the vector sign. V without the vector sign means we are talking about the magnitude of V, and the magnitude of V becomes instantaneous velocity. Do we understand this?
Yes,
So
sir.
now you can write one more important point here. It is the instantaneous speed is the magnitude of
in, instantaneous
instantaneous
velocity.
velocity. Do we understand this?
Yes, sir.
Instantaneous speed is the magnitude of instantaneous velocity.
Done, sir.
Do we understand this?
Yes, sir.
Now you can also write if a particle is moving with constant velocity. If a particle is moving with constant velocity for uniform or constant velocity, your average velocity will become equal to your instantaneous velocity, because you are covering equal distances in equal intervals of time. Yes or no? No, yes.
Yes, sir. Yes.
That is how you can understand instantaneous velocity, average velocity, instantaneous speed, and average speed. Do we understand this?
Yes, sir.
Anyone having any doubt on this? Shall I give you a question that you can solve?
Okay, sir.
Okay, then I will give you a question right over here. A car moves 10 meters n. N coming, what is the meaning of n?
North,
Then 20 meters e.
east,
Total time is 5 seconds. Fine. I will only write symbols. L, what do you mean by L?
length. I mean, like distance.
Delta R vector. What do you mean by this? Total displacement.
With
What do you mean by this?
average velocity,
What do you mean by this?
average speed.
You have 5 minutes to do this. Yes, bacha. Do we have an answer?
Yes, sir. Sir, the distance is 30 meters.
Speak loudly.
The distance is 30 meters.
The distance is 30 meters. Okay, let me write the solution. Solution. The distance L is, it moves 10 meter north, 20 meter east. Distance has got nothing to do with the direction of travel. The total distance traveled is 30 meters. Yes or no?
Yes, sir.
No doubts on this one, I hope. Then let us talk about the displacement. Remember, displacement has two things,
Magnitude and direction.
magnitude and direction. So what is the magnitude of displacement?
15 root 5.
Yes?
10 root 5.
Okay, if I just draw it here, first of all, let me draw it. He starts from this point O, then he moves. This is just to explain that how we are doing it from here to here, then from here to here. This is 10 meters and this is 20 meters. Yes or no?
Yes, sir.
The displacement is this vector, AB vector. Yes or no?
Yes, sir.
And I'm asking you its magnitude as well as its direction. So tell me what is the magnitude and tell me what is the direction.
Magnitude is 10 root 5, sir. Direction
Oh, why this has gone here? I don't understand. Just give me. Yes, better. Magnitude is
10 root 5
magnitude is 10 root 5 meters, and you can say the
meters.
direction in terms of this angle. Yes or no?
Yes, sir. Tan inverse 2.
Tan theta would be equal to 2. We all understand this? Yes or no?
Uh,
You all understand
Direction
this?
is tan inverse 2.
Yes, tan inverse 2. That is correct. We understand this, everyone?
Yes, sir.
Let us now move on to the next point where we find out the average velocity. And average velocity is total displacement divided by
My
total
time.
time. Again, it will have two components. One is the magnitude. What is the magnitude of
One
that?
is
So 10 root 5 divided
5
by
by
5.
5.
So it
2
will
root
be
5.
2 root 5. And what is the direction? The direction is in the direction of displacement. So
Tan
it is.
theta is equal to 2.
Do we understand this? Yes or no?
Yes, sir.
Now let us talk about the last thing, which is the average speed.
Speed 6 meter per second.
Total distance divided by total time. 10 plus 20 is 30. L divided by T. So you have 30 divided by 5. It is 6 meters per second. Do we understand this? Yes or no?
Yes, sir.
So this is how we can find out the average speed and average velocity. Anyone having any doubt, please raise.
No, sir.
Pakka?
No, sir.
Okay. Shall we
Yes.
move ahead in life?
Yes, sir.
Okay, now what we'll do is we will write some important points about this average speed and average velocity where we might be having some doubts. So what we will do is we will write them as point.
Okay, sir.
Comparison between average speed and average velocity. Okay, here it comes. Comparison between average speed and average velocity. Average speed is a scalar quantity. Do we understand this?
Yes, sir.
Average velocity is a vector quantity.
Vector quantity.
They have the same units and same dimensions. Apart from this, there is no relation between them. Do we understand this?
Yes, sir.
Because they are defined in different ways. Average speed is total distance divided by total time. Average velocity is total displacement divided by total time. There is no relation between them. Yes or no?
Yes, sir. Done, sir.
Done, sir?
Yes, sir.
Then average speed and average velocity depends on the time interval. They are always defined over a time interval. Yes or no?
Yes, sir.
So they are always defined over a time interval.
Interval. Yes, sir.
Written this?
Yes, sir.
Okay, then comes the next one. For a given time interval, average velocity, it does not depend on path. Do we understand this? Because it is total displacement. It does not depend on
Path.
It does not depend on path, and therefore, for a given time interval, it will be same.
Yes, sir.
But average speed depends on
Path.
average speed. The green one depends on path. Therefore, it can have different values. Do we understand this? This is
Yes.
again a revision of what we are doing.
Yes, sir.
For distance and displacement, whatever things we had read about distance and displacement, my dear friends, the same things as you can see are coming back. Yes or no? No or yes?
Yes, sir.
Revision of distance and displacement. Comes the next point. If the particle comes back to its initial position, the average velocity will be how much? 0.
No.
But the average speed
0.
will not be 0. They have written v for speed and v vector for velocity. Do we understand this? Yes or no? No, yes.
Yes, sir.
Same points that we had seen for distance and displacement. The same points have come back. Yes or no? No, yes.
Yes, sir.
Do we understand this?
Yes, sir.
Then comes the last point. For a moving body, average velocity, average speed cannot be negative or 0 because total distance cannot be negative or 0. But average velocity, depending on the direction, you can call one velocity as positive and the next velocity as negative, because positive or negative refers to its
Direction.
Do we understand this?
Yes, sir.
Remember the magnitude of average velocity. This is the magnitude of average velocity is always greater than 0. Do we understand this?
Yes, sir.
The magnitude of displacement is always greater than 0. The magnitude of average velocity will always be greater than 0. It's only because of the direction. We can call one displacement as positive, the other displacement becomes negative. Therefore, one average velocity in one direction would become positive. The average velocity in the other direction would look like negative. Do we understand this?
Yes, sir.
And the next thing is trying to understand between instantaneous speed and instantaneous velocity. We have already discussed that. Comparison between instantaneous speed and instantaneous velocity. Then the first point is this. Remember, instantaneous velocity is instantaneous speed with direction. Yes or no? No, yes.
Yes, sir.
Now, when you talk about the direction of instantaneous velocity, and this is a very important point, the direction of instantaneous velocity is always tangential to the path. What do you mean by tangential to the path? If a particle is moving not in a straight line, remember the name of this chapter is motion in a straight
In a
line,
straight line.
but these definitions are not restricted to straight line only. Do we understand this?
Yes, sir.
These definitions are valid in all cases, and therefore the direction of instantaneous velocity is always tangential to the path. This is an example of something known as parabolic motion. Yes or no?
Yes, sir.
Now, at any given point, if you can look at the velocity direction, these are all instantaneous velocities. It is always tangential to the path followed. Do we understand this? Yes or no? No, yes.
Yes, sir.
So direction of instantaneous velocity is always parallel
Tangential to the path.
to the path followed by the body. Do we understand this?
Yes, sir.
Are you noting it down? Yes or no?
Done, sir.
Done, sir. Then this point, sir. A particle may have constant instantaneous speed. So its speed may remain constant, but the velocity may
velocity is
keep on
variable.
changing. Why it can keep on changing? Because the direction can keep on changing. Yes or no? No, yes.
Yes, sir. Yes, sir.
These are all the points that will come as questions in your exam, bacha. The next point, the magnitude of instantaneous velocity is equal to instantaneous speed. Yes or no? No, yes. We understand this.
Yes, sir.
We have discussed this many times.
Yes, sir. Done, sir.
Then, sir, if a particle is moving with uniform velocity or constant velocity, then its instantaneous velocity and average velocity will remain same. We have discussed this point. Yes or no?
Yes, sir.
Similarly, when it is moving with constant speed, its instantaneous speed and average speed will remain constant. Yes or no? No, yes.
Yes, sir. Done, sir.
Then can come to this point and we will do an example for this point so that you understand this point. Well, sometimes you will be given displacement or position of the particle as a function of time. In some cases, it will be called as displacement. If it has to be correct, it has to be called the position.
vector.
If the position vector of the particle or position of the particle is given as a function of time, then the time derivative. You understand the meaning of derivative? Yes or no?
Yes, sir.
In the time derivative, if this is the displacement, then the derivative of this thing dx by dt or dr by dt, the derivative of this entire thing will give you the instantaneous velocity. Yes or no?
Yes, sir.
Because this velocity will come as a function of time. You put the value of t, you will get the instantaneous velocity. Remember, to find out the average velocity, you will have to find out the total displacement and then divide it by the total time. Don't worry. We will do a question that will help us in understanding this concept. Have you noted this down? Yes or no? No, yes.
No, sir. Once.
Please note it down. Then I'll give you a question, my dear friends. Are we ready?
Yes, sir.
So here comes the question, and I'll give you 2 minutes to solve this. The motion of a particle is described by the equation, this one. What is this x? What is this a? What is this b? What is this t? X is the position or the displacement, yes or no?
Yes, sir.
A and b. A is given as 15 centimeters, b is given as 3 centimeters. A and b are some constants.
Yes,
T
sir.
is time, yes or no?
Yes, sir.
Can you find its instantaneous velocity at time 3 seconds? I'll give you 2 minutes to solve this question. Yes, Bacha, do you have the answer? How will I get the instantaneous velocity at time t is equal to 3 seconds? Shall I do it? So instantaneous velocity is dr or dx by dt, yes or no?
Yes, sir. Dx by dt.
Here we are not using vectors because it is moving in a straight line, so I can call it positive or negative, yes or no?
Yes, sir.
So I will differentiate it d by dt of
A plus
a plus
B,
bt square. I
BT
hope you know how
square.
to differentiate, yes or no?
Yes, sir.
So derivative of a will be 0, the derivative of bt square will
It
be
will
2bt,
be
yes or no?
yes, sir.
2 into b into t. The value of b is 3. The value of time is given as 3 seconds. So you can write velocity v as, remember I will always use v for velocity and s for speed. The velocity v, I'm not using a vector sign because it is only moving in that one direction. The velocity at 3 seconds, so I write v3. Velocity at 3 seconds will be how much? Yes, bacha.
18, sir.
18 centimeters per second. Yes or no? No or yes? Do we understand this? Everyone got this answer?
Yes, sir.
Not looking confident. Everyone got this answer? Yes or no?
Yes, sir.
That was the instantaneous velocity. I will add one more question here. Find the average velocity from 0 to 3 seconds, so that you understand the difference between the two quantities, and you also understand how you can find out the average value, find out the average velocity. It was not a part of this question. I have made it for you so that you understand the difference between average and instantaneous value. I'll give you a minute, 2 minutes to do this. Are you confident that you can do this? Yes or no? No or yes?
Yes, sir.
Well done, sir. That is good, sir. I like this, sir.
6, sir. 6.
You got the answer also, sir. Well done, sir. Tell me, sir, how, sir? How, sir? Tell me, sir.
6, sir.
What, sir?
6.
6. 18 divided by 3 is 6, right? That is wrong, sir. So may I ask you the definition of average velocity, sir?
Total distance, total displacement by total time taken.
Did you find out the total displacement and then divide it by total time? Or you are... There is a very famous story of Arjun and Bhim. Have you heard about this? I'll tell you. I'm good with mythology and I like telling stories. So there was a point in time when Bhim Bhaiya, because he was elder than Arjun, Bhim Bhaiya he was sitting in the kitchen and he used to eat a lot. He was sitting in the kitchen in pitch dark. It was complete darkness over there. And he was galloping food. He was eating food. Arjun came there and said, "Oh, Bhim Bhaiya, what are you doing?" He said, "Ki main khana kha raha hu, I'm having my food." Then he asked him, "It's so pitch dark, you can't hardly see anything. How can you eat in such darkness? How do you see food? There's nothing to see here. I know where the table is. I know where the food is. I know where my hands are. I know where my mouth is. What I need to see, I'll put my hand, it will go in the food. The food will come and it will automatically come in my mouth." Arjuna got surprised. Okay, that's great. There is no need of seeing it. He went outside. It was pitch dark. There was no light, no electricity at that time. And it was a Amavasya Kirat, no moon day. He set up a target and he started hitting arrows. And all of those arrows, obviously, it was Arjun. All of those arrows were hitting the target. Guru Drona came there. He said, "Oh, Arjun, how can you hit arrows in the dark? You can't see anything." He said, "Sir, why do I need to see? I know where is the target. I know where is my bow. I know where is my arrow. I'm hitting them. And they are striking the target." Arjun could hit arrows in dark and they would hit the target because he was Arjun. We can't do the same. We can't hit arrows in the dark, dum, 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 and end up killing a lot of people just for our ambition of hitting arrows in the dark. Can't hit arrows in the dark. Only Arjun and probably Samrat Prithviraj Chauhan could hit arrows in the dark. He was blind and he hit and he killed Muhammad Ghori right in the eye. He can do this. We are not Arjun. We are not Prithviraj Chauhan. So we'll have to use the definition and then find out the answer. The definition says total displacement divided by total time. So don't hit arrows in the dark. One day when you become Arjun, I can't obviously become Drona, but you can definitely become Arjuns or female Arjuns or male and female doesn't matter. Arjun is Arjun. The gender doesn't matter. Then you can hit arrows in the dark and then your arrows will start hitting the target. But for that, you'll have to practice. Just dividing 18 by 3 was you look 18 and 3 and 18 divided 18 by 3 and you're done. No, that is not going to give us anywhere. So now try again. Arjun did not become Arjun, he was not born Arjun. Oh, his name was Arjun when he was born. But he did not start hitting that arrow from the very first arrow target. No, practiced. 2 minutes more. Remember the definition. Guru Drona also told Arjun how to do it. But he has to do it on a... Guru Drona could not transform his Atma into Arjun and say, okay, I will transform. As soon as the war comes, I will transform my Atma into yours and then you will become Guru Drona and you will get everything that I have. No. Because if that would have been the case in Mahabharata, the Pandavas would have lost because Guru Drona could not come inside Arjun to help Arjun out because Guru Drona was on the other side. Right? So Arjun had to take the bow and arrow in his own hands and kill Guru Drona, obviously by deceit. Ashwathama is dead. Ashwathama was his son. But the elephant Ashwatthama died, and Guru Dron just put his bow and arrow, and he just put a arrow right through the teacher's heart. Dharm ki ladai mein you have to sometimes do such things. Anyways, dharm and adharm, here we are. Mythology lesson in the class of physics. I hope it helps. Apart from bringing smiles, it might also bring the correct answer. Okay. My humble duty now to do it. So I have to find total displacement. So I find x0. Oops, wrong color. I don't like doing wrong color. X0. So that means my displacement or position at time 0. So I put the value of x as I put the value of t as 0. So my x0 becomes a. Yes or no?
Yes, sir.
That is my position at time 0 seconds. Yes or no?
Yes, sir.
Then I put from 0 to 3, I have to calculate. So I now put the value of time as 3 seconds, and I find out the displacement at 3 seconds, all the position at 3 seconds. So x3, the displacement or position at 3 seconds will be, I put the value of time as 3 seconds. It will be a plus b into 3 square. 3 square is 9. So it will be a plus 9b. Yes or no? No or yes?
Yes, sir. Yes.
Now I find total displacement. Yes or no? No or yes?
Yes, sir.
I find total displacement delta x or delta r. Final position minus initial position. So what is the total displacement? It is 9 times b. Yes or no?
Yes, sir.
9 times b. B is how much? 3. So 9 into 3 is 27. Total displacement is 27 plus or minus plus and plus 27 is in the same direction. Yes or no?
Yes, sir.
Now can you tell me, my dear friends, what is the average velocity?
Nine, sir.
27 divided by 3. Total displacement is 27 divided by total time is 3. 9 centimeters per second. And remember, it has got nothing to do with your instantaneous velocity. Your instantaneous velocity was found out in a totally different way. Your average velocity was found out in a totally different way, and they are coming same because this particle is not moving with uniform velocity. If it was moving with uniform velocity, both the values would have come same. Do we understand this, or this is gone above our head saying bye 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 bye, I'm going? Understand this?
Yes.
Akka?
Yes, sir.
Chalo. What's happening? This was supposedly on do not disturb. Why is everyone calling me? Okay. I'll give you one question that you should solve to understand this concept more clearly. Okay.
Okay, sir.
So here comes the question. The position of a particle is given by this formula 2t square plus 3t plus 5. Okay.
Yes, sir.
So that is the position of the particle. Find x0, x5, v0, v5, and V average. I've written everything in the form of symbols. Do we understand the symbols?
Yes, sir.
X0 stands for position at 0 seconds. X5 stands for position at 5 seconds. V0 stands for velocity at 0 seconds. V5 stands for velocity at 5 seconds. V average 0 to 5 stands for average velocity. Remember, average velocity is always calculated over a interval of time. You have 2 minutes to do this. Shall I do it for you?
No, sir, we are doing.
So, first things first, let us find out the value of x0. What is the value of x0?
So it's 5.
X0 is, oops, wrong color. Why I use wrong colors? I hate wrong colors. Okay, x0 is 5.
Yes, sir.
X5, just put the value of time as 5.
7. 70, sir.
Pakka na?
Yes, sir.
Okay. Now to find out velocity, let me first differentiate dx by dt. Yes or no?
Yes, sir.
So it will be 4t
40
plus
plus
3. Yes
3.
or no?
Yes, sir.
Let me find out the value of v0.
3.
It is 3 meter per second. So this is the instantaneous velocity at 0 seconds. Do we understand this?
Yes, sir.
This is the instantaneous velocity at 0 seconds. This is
Yes,
the
sir.
position at 0 seconds. This is the position at 5 seconds. Yes or no?
Yes, sir.
Let me find out the value of V5. What is this?
23 by 5.
Let me find out the value of V5. V5, just put the value of T as 5. How much?
23 by 5.
23 meter per second. That is the answer that I will get. That is the value of V5. Now let us calculate the value of V average. V dabba from 0 to 5. Total displacement is how much? Final position is 70 minus 5.
70
Initial position is
minus
5 divided by 5. So 65 by 5, I think it's 13, right?
Yes, sir.
So V dabba is 13 meter per second. As you can see, it has got no relation between this quantity or this quantity. It is a totally different quantity segregated from all of these. Do we understand this?
Yes, sir.
Everyone got this answer? That means we are good to move ahead in life. We have taken some definite steps in understanding this motion in one dimension. In the next class, we will move on to the third step. What is the third step? Speed is done, velocity is done, distance and displacement are definitely done. Then what is the third step?
Acceleration.
Acceleration comes into the picture and the equation of motion come into the picture in the same class. So we will do that. And I hope before coming to the class, in the next class, you will do the question that we have done and you'll go through and probably you will get the,
Sure, sir.
you have got that sheet?
Yes, sir.
Try question from that sheet up till acceleration. They are given in sections. Distance and displacement is given different. Velocity and speed are given different. So to those parts,
Yes, sir.
whether they are in the sheet or in the module, do them. As more the number of questions you do, the more is the probability that you can hit arrows in the dark, and those even those arrows are going to hit on the target. Okay, take care.
Okay, sir.
Have a nice day.
Thank you, sir.
God
Thank
bless
you.
you
Have
all.
a nice day.